Today we're going to be looking at transformations of linear and absolute value functions. All right, a couple state standards that you need to be aware of. And your success criteria. Today, to be successful, you need to be able to write functions that represent transformations of linear functions and write functions that represent transformations of absolute value functions. So what are we going to be able to do today? We're going to be able to write functions. All right, a couple key ideas. Here, horizontal translations, you can see what's happening. It is moving left or right, which is your horizontal or along your x-axis. When that happens, that's going to be a movement next to your x. You can see the h is inside parentheses, so it's x minus h in both of these cases. All right, a vertical translation is going to be along the y-axis. So your vertical translation is going to be up or down. So you can see k is outside of the parentheses. It's not next to your x because it's y equals f of x plus k. So it's going to move up or down depending on what k is. All right, study tip. When you reflect a graph over a line, the graphs are symmetric about that line. So that's important to know. All right, a couple more things, key ideas to make sure you know. Reflections in the x-axis. So if the graph of y equals negative f of x, that's a reflection across the x-axis. Okay, you can see here it is taking the line and it is reflecting. If you had a point here, it would reflect to here. If you had a point here, it would reflect down here. Reflection across the y-axis, again, that's f of parentheses negative x, so that's inside. So if the negative is inside the parentheses, it's reflecting across the y. If it's outside, if it's in front of, it's reflecting across the x. All right, you've got horizontal stretches and shrinks as well. So remember, again, that depends on what your values of a are. This is good information. Please review that because we are going to go over some of these examples, but it's handy to have this to look back on in your notes. All right, example 1, writing translations of functions. A part says, write a function g whose graph is a translation 3 units down of the graph of f. B part, write a function h whose graph is a translation 2 units left of the graph of f. All right, so right here is your key ideas again. We are going to be writing a function, so let's get started. All right, for A part, it says write a function g. So we're going to have g of x. And what does g of x equal? G of x is the graph of a translation 3 units down of the graph of f. So we're going to have f of x, and we're going to take it minus 3. So you can do plus a negative 3 if you want, because if you look over here, you can see that this is always plus k. So it's plus k is negative 3 because it's going down. All right, so what is f? They give us f. F of x equals 2x plus 1. So we can say 2x plus 1 is going to substitute in place of f of x. And then plus negative 3 is still here. All right, so we can combine like terms, plus 1 and plus negative 3. So 1 minus 3 is negative 2. So we're going to have 2x minus 2. So that's g of x. All right, B part says write a function h. So we're going to have h of x, whose graph is a translation 2 units left. Okay, so this time it's going to be a horizontal translation. The last time it was a vertical translation because it went down. All right, this time it's going to go left. All right, so if it goes left, it's going to be minus h. So we're going to have f of x. And this time, since it's horizontal, it means our value is going to be inside our parentheses. So we're going to have f of x minus, and then 2 units to the left. To the left is negative 2. All right, so that's the same thing as f of x. Negative 2 is x plus 2. All right, now we can take the function. Our original function here, f, is 2 times x plus 1. All right, so instead of 2 times x, we're going to put our new value here. So we're going to have 2, and again, this is coming from f of x, 2 times x, but instead of x, we're going to have x plus 2 because we're plugging in our new value from right here. And then we still have the plus 1, and then we're going to have to simplify. So we're going to have h of x equals, and we're going to have 2x. If I distribute 2x and 2 times 2 is 4, and plus 1, so that becomes h of x. When I combine like terms, I have 2x, and 4 plus 1 is 5. So we wrote a function for h of x, and we wrote a function for g of x using the given information. And since both of these are transformations of the original function f of x, if you graphed all three of these, you should be able to see if it did exactly what it told you to do. So that's a way to check it. I like to visually see what's going on when we're talking about writing functions. So just take your graphing calculator, type those in, and it's an easy way to see those graphs, all three of them. Example 2 says writing reflections of functions. Let f of x equal the absolute value of x plus 3 plus 1. All right, so it says write a function g whose graph is a reflection about the x-axis. And then h will be a reflection across the y-axis. All right, so for a part, we're going to have g of x. And we know that f of x is a reflection across the x-axis, so it's going to be negative f of x. All right, now we want to have the opposite of f of x. So we know f of x equals the absolute value of x plus 3 plus 1. So we're simply going to substitute that in. So we're going to have g of x equals negative. Now instead of f of x, we're going to replace this with the actual function, x plus 3, and then plus 1. All right, and actually, that's negative the whole function, so that needs to be in parentheses. So we're going to have negative the whole function f of x. So since this whole thing is going to be negative, we have to have that negative sign here. So when we distribute the negative sign, we're going to have negative times the absolute value of x plus 3, and then negative times positive 1 is negative 1. All right, so the reflection g of x equals negative absolute value of x plus 3 and then minus 1. All right, B part says the function h, so we're going to have h of x is a reflection about the y-axis. All right, if you see over here, if it's a reflection about the y-axis, that means it's f of negative x. So we're going to have f of negative x. And then we're simply going to plug in our function like we did before. So we're going to have our function, and we're going to have the absolute value of x, but now instead of x, we're going to have negative x plus 3, because this time we're changing the value of x, not y. Remember, f of x is the same as y, so we were changing the whole function. This time we're just changing the x value. All right, now you can all right, we could stop here, but we can write it a little bit nicer than this. So if we look at this, we don't like to leave this as a negative value for the leading coefficient here inside the absolute value. So what we can do is factor out a -1. So if I factor out a -1, I'm going to factor out a -1 from both terms inside my absolute value. So that's going to leave me -1 times x, and then -1 times -3 is +3. And if I do that, I can use the product property of absolute value to separate these, and I can have the absolute value of -1 and then times the absolute value of x minus 3 and then plus 1. All right, when I do that, the absolute value of -1 is just 1, so that kind of disappears, and it leaves the function absolute value of x minus 3 plus 1. So this is the nicer looking function. Again, you could leave it. It is equivalent to this function right here. But we don't often see a negative here with this x. So, if this number is negative, that's just a binomial. But anytime we have a leading coefficient that's negative in the binomial, we usually factor that negative out. So here is g of x. And here's h of x. Again, if you want to see what those look like, use your graphing calculator to graph the parent function, and then both a and b to see if the functions we wrote look like a reflection across the x and y axis. All right, we have a self-assessment here. It says to write a function g whose graph represents the indicated transformation of the graph of f. Use technology to check your answer. All right, so it gives you f of x. They want you to reflect it across the x, and then f of x reflected across the y. So what I want you to do is pause the video, just take a few minutes, do this on your own. The best way to see if you're learning what I'm saying is to practice. So do these on your own and then come back to check it. Example 3, writing stretches and shrinks of functions. All right, study tip, the graphs of y equal f of -ax and y equals -a times f of x represents a stretch or a shrink and a reflection in the x or y axis of the graph of y equals f of x. All right, so it says let f of x equal absolute value of x minus 3 minus 5. Write a function g whose graph is a horizontal shrink of the graph by f by a factor of 1/3. All right, let's just look at a part first. All right, this sometimes confuses people, so I want to make this clear. So we're looking at g of x. So right here, when we're doing a horizontal stretch and shrink, all right, anytime we're doing a horizontal, that means a, the value of a is inside the parentheses here. That we have to do it by a factor of 1/a. So if this is a factor of 1/3, let's come up here all the way, 1/1/3 is actually going to be 1 times 3/1, which is just 3. All right, so we're using the number 3 instead of 1/3, even though we're doing a horizontal shrink by a factor of 1/3. So in g of x equals, we're going to have f of, and it's going to be 1/a, which is the 3, not the 1/3. So we're going to have 3x. All right, and then we can say our function is absolute value of x minus 3. So we're going to have 3x in place of x minus 3 minus 5. All right, so the transform function is g of x equals absolute value of 3x minus 3 minus 5. All right, we are just about out of time for this video, so we'll do B part in the next video.